Let's have a look at the new Inlet Box Features. So I've got a duty up here. So on accessories now, if we look at the Evase, it's also Evase Reducer. So we've got an area ratio, so that's going to be the Evase area, but we might want to specify the outlet area required. That would be to match some existing ducting. So let's do that. We'll also put on an inlet box and we'll make the inlet box area match the outlet area. So at the moment the default area that Centrix will pick gives us an outlet velocity of 20 meters per second. Of course we can change this, enter our own value in there, which gives us a higher velocity, etc. And because we've got this matching, and we've got the same velocity here, and we're allowing reduction factors. So if that at the moment is set at 0.5, so let's use 0.75 on both and see what we get. We'll do a survey to speed things up a bit. So let's go next and see what we get. So now we've got some colour highlights here. So where we've got an outlet reducer is this colour. So the outlet velocity meets the specification and it's a reducer. If it's an Evase, that meets the specification and it's this colour. Now the inlet box area is limited for these fans here. These are very large sizes. So let's have a look at maybe one that's not too large but has a restricted inlet box. So let's have a look at this 25. So if we have a look in this area here, we've got the casing outlet size, the fan outlet velocity, the reducer velocity is what we wanted. And the other thing to note is the casing width required is this value here compared to the standard width of that one. I'll come back to that in a minute. And let's have a look at the inlet box. So the inlet box has got a lower velocity, and that's because we reached the limit of the reduction that we specified. So the standard inlet box area was reduced by this 0.75. So let's just go back and have a look at the accessories, and we want to get that now. Let's view the fan detail and curve again. So the inlet box needs an area ratio of 0.71. So let's view accessories, and I'm going to unlock this box so that it can be recalculated, and I'll change that to 0.7, and we'll apply that. We'll say yes. We've got some new losses, slightly more losses because of the higher velocity through the box, and we can see that the curve is just falling slightly below the duty point. In fact, it's so close it hardly makes any difference. Now, I did highlight this business of the casing width required, which is 1059, to get rid of the actual reducer. So I'm going to copy that with the Control-C, and I'll go next, and I'll paste that in there. So I'm going to reduce the standard casing width. Oh, I want it to do that. Paste. That's why. Okay, 1059. So let's apply, okay, and go back. So now we're actually closer because we don't have losses through that reducer. And we see now that the reducer has come out of here. So that's been adjusted from 1366. So let me just change that back yet again. Paste and apply. And just go back and let's see, we've got the reducer. So let's have a look at a bit more of this. Keep going next. I'll use a belt drive fan. And now we see that the box velocity exceeds the inlet cone velocity, which is not really supposed to. So we can click on here to get a bit more information. And it's telling us that the maximum inlet cone large diameter should be 1596 to get the inlet cone velocity equal to the box velocity. And so we'll say yes there. And what's that, 1596? Now I'm going to need to draw that to make sure it looks all right. Well, we've still got a reasonable angle there for the cone. So now we can close that, and we've got rid of that warning. So let's go next and next. We might just change the shaft material here. Apply that, that's okay. And let's have a look at the inlet assembly. Now this is a very wide casing. So if we were to change the casing width, it would bring this over here. So let's have a look and see how far we'd like to come at a maximum. So if we went to somewhere, say here, that would be about 1186, say. So let's view the casing materials. Now 13, let's go back then, we can't remember what it was, let's just pick it up, 1059, and we had 1186. So let's go say 1100. Okay, so let's now go straight to the shaft design and have a look at the inlet assembly. Okay, so now we've got a much narrower casing. So we've got rid of that reducer, or most of that reducer, and we could even make this a bit smaller if we wanted to, but the more we increase the velocity through the inlet box, the higher the losses will be. So that could be our final design. So we've saved some material with a narrow width casing and a smaller box. So now if we can click and just have a look at the layout in the other view, and that looks quite reasonable for an inlet box. So the other thing we can do is we can play around with some of these values if we wanted to, say, do some rounding. We've also got the outlet size specified here, and we've got a reference diameter. So the reference diameter is based on the hole for the inlet cone. So if we look at the outlet size, the biggest dimension we've got for the outlet is 1663. So we wouldn't want to make the box. Ideally, we'd like to make the box the same size as the outlet, but we can't do that because we're restricted by the diameter. So what we could try and do is maybe square this off a bit, make that 2000, then calculate that one. So now it's 2:1 aspect ratio. We might like to redo the bottom width, bottom depth, the drop below the centre line. We'll keep that the same. Let's just draw that. So now we've got an even smaller box, but it's got the same velocity. So let's have a look now at the curve. And we're still okay, we're still on the duty point. What else have we got here for this inlet box? We've got a flat back height, which so far is not working, but that will be introduced soon. Angles, so I've made it integral with the casing side here. That's because of the changing the small cone. So if we do that, then Centrix will automatically make this integral with the casing side so that we can use a much smaller cone. With splitter plate, if we were to make this a separate box, then you can see that it's very tight, because now the inlet matches the, let's have a look, let's go back and okay, so we've got a little bit astray now because the reference diameter is bigger than this width here. So let's make it integral. Okay.